All right, let's look at the homework 7.8, problem number 8. All right, so we want to use the comparison theorem to determine whether this improper integral is convergent or divergent. All right, so let's do that. First, I'm going to do a little bit of ballparking. All right, so I'm going to look at the leading term on top and also the leading term on the bottom. All right, so you can see that this is roughly x over, let's say, square root of x to the fourth is x squared, right? Which is really the same thing as 1 over x by canceling out the x, right? Then 1 over x, integral from 1 to infinity of 1 over x is going to give you natural log of absolute value of x, which is going to actually diverge. So we are heading toward the concluding that it's going to be divergent. So what we want to do is we want to find something smaller and but still diverges. All right, so let's do that. All right, so I'm going to start with, let's see, 4 times, all right, x plus 1 over square root of x to the fourth minus x. All right, I'm going to make it smaller by simply removing 4. So I'm going to shrink to 1/4 of the original size. So you have x plus 1 over square root of x to the fourth minus x. Right? And I'm going to make it even smaller by removing 1 from the numerator. So since I'm making the numerator smaller, the whole fraction, of course, gets smaller. Right? Right? And the next step is I'm going to actually remove negative x, so which means that I'm adding x inside the square root on the bottom, which means that I'm actually making the denominator larger, so the fraction gets smaller, right? Then you can see that this is actually just x over x squared, which is equivalent to 1 over x. Right, so we could establish that 1 over x is actually smaller or equal to 4 times x plus 1 over square root of x to the fourth minus x. All right, so all we have to do is just to verify that the integral from 1 to infinity of the smaller one, which is 1 over x with respect to x, is going to diverge too. So we have a limit. All right, here's the troublemaker. We don't want infinity there, so I'm going to have to use a limit as t approaches infinity. Integral goes from 1 to t, then 1 over x dt. All right, so I'm going to leave the limit alone for now. So limit as t approaches infinity. Antiderivative of 1 over x is natural log of absolute value of x, and going from 1 to t, right? Then we still have to have a limit here, right? Plug in the first one, so you have a natural log of absolute value of t minus natural log of absolute value of 1, right? But natural log of 1 is 0, so this guy basically goes away, right? But as t approaches infinity, natural log of infinity approaches infinity, right? So therefore, we have a positive infinity, which indicates that this is going to be divergent, right? So by comparison theorem, since the smaller function, improper integral diverges, so the original one is even larger, so this guy is also diverges. All right, so let's answer this question. Let's say it's diverges. All right, let's check the answer. Submit for testing. All right, I came back and looks like we got this one correctly, right? So maybe I should say this is by comparison theorem. Right? That's it. I hope that this was clear.